In this video, I want to talk about an application of exponential functions. Specifically, I want to talk about applying exponential functions to calculating how much money you have in an investment after a certain number of years if it grows at a certain average rate. All right, so for example, let's do this. How much will you have in a bank account that pays 2% per year after 10 years if you initially deposited $500? How much will you have in a bank account that pays 2% per year after 10 years if you initially deposited $500? So how would we calculate that? Well, let's just use our common sense. So after 1 year, we're going to have 500 times, well, we're still going to have 500, so we're going to have 500 plus whatever 2% of 500 is. And I'm going to write it in this convoluted way just to try to point out a pattern shortly. So it'll be 500 plus 2% of that, which would be 2% of 500 is 500 times 0.02, right? Now, in the second, and let me rewrite that. That is equal to, if I factor out the 500, 500 times 1 plus 0.02, right? Or 500 times 1.02. So apparently, to calculate how much money you have after a year, you multiply what you started the year with by 1.02. Okay? And that's going to be true for future years. So in the second year, how much did I start the second year with? Well, 500 times 1.02. And so in order to figure out how much I have at the end of that year, I'm going to multiply that by 1.02. All right, in the third year, same thing. I write what I started the year with, and I apparently multiply that by 1.02. Okay, now each year, how many 1.02s are you going to have in the product? Can you see that you're going to have the same number as the year that it is? So year 1, you had one single 1.02. Year 3, you had 3 of them. If you wanted to know how much money you're going to have after 10 years, you would do 500 times 1.02 to the 10th power, right? Okay, here is the in a nutshell how you do compound interest calculations. So the exponential function that you want is, putting it in a general form, is d times 1 plus r divided by 100 times y. This will give you how much money you have if D is the initial amount you started with, and then R is the rate of interest, and then Y is the number of years that have passed. And this is the general form that you would get if you did the example, you worked it out similarly for other numbers. Okay? So let's use this immediately in another example. Okay? So write down this formula that I just gave you, and then see if you can apply it to this next question. An investment of $10,000 grows at 15% on average every year for 5 years. How much will it be worth after those 5 years? All right, so pause the video and try to set up the formula to calculate that. Okay, so using what I just gave you, here's what I would say. Okay, I would punch that into my calculator. All right, notice that R, what I called R the rate, that's if you have 15%, then it's whatever that number is, that integer. Okay, in this case, it doesn't have to be an integer, but in this case it was. All right, sometimes there's a confusion about whether R means the decimal, or so like, do you mean for R, for 15%, is R 15 or is it 0.15? The way I'm writing the equation, I'm saying that for this example it was 1.5, and to convert to a decimal, that's why I divided by 100. Okay, so I hope that makes sense. Now, what is another twist that we need to be aware of is sometimes all that money that the bank pays you for the year is not all paid all at once at the very end of the year. All right, sometimes they pay it in installments, in pieces. So for example, suppose that you made, so in this example, let's $10,000, 15% of that would be $150 after the first year, right? Suppose instead of waiting the whole year to give you $150, suppose that a bank, this was a bank that was, this was money in the bank instead. Let's do a slightly different scenario. So instead of paying you $150 after 12 months, what if they paid you half of that, so $75 after 6 months, and then another $75 after the next 6 months? All right? It would seem that that wouldn't make much of a difference paying it in pieces, but actually, you remember, you make money for, you make profit for the more money that you have for the more amount of time. So if they pay you sooner, that's more money that you have in the bank growing. Okay? I can give you the equation, I will give you the equation for how to adjust for these different types of compounding. Okay? Clearly, if you're going to pay the 150 3 times, then you're going to pay $50 each time. All right? If you're going to pay it 2 times, you're going to pay $75 each time. If you're going to pay N is in Nancy, okay, keeping it general now, or making it general. If you're going to pay N times, you're going to pay 150 divided by N. Okay? You're going to have more payments, but each one of those payments is going to be smaller. All right? So here's how you would adjust the original equation. Let me write the original equation here. It was D and then 1 plus R over 100 times Y. Okay? So now if you have N payments per year, what's going to happen is you're going to get a lot more payments of smaller amounts. So the smaller amount is going to be, instead of R over 100, we're going to divide that by N. Those are the smaller amounts of payments. Or that's how we're going to turn it into a smaller number, I mean. And then to increase the number of payments, we're going to multiply the exponent by N. Okay? So that is the equation for different types of compounding. So if it was compounded monthly, N would be 12. If it was compounded biannually, every 6 months, N would be 2. If it was compounded daily, N would be 365. Okay? So write that equation down and let's use it in an example. All right? So here we go. A bank pays 4% interest compounded quarterly. How much will $100 be worth after 7 years? Think about that. See if you can answer that question and use the equation I just gave you. All right? So I'll go ahead and work it out. You can pause the video if you want to try it. So for this one, the amount that you started with was $100. The interest rate is 4. So R is 4%, so R is 4. And quarterly, what does that mean? Oh, by the way, Y is 7 years. Quarterly means there's 4 quarters in a year, so N is 4. We're going to get 4 payments per year. So putting it all together, we have in our formula 100, 1 plus 4 over 100 times 4, and then we wanted it for 7 years, so 7 times 4. So I would punch that into my calculator, and that will give me how much I'm going to have after 7 years. All right, isn't that cool? Now, hopefully that makes sense now. Now, the only other little interesting twist that we need to talk about is sometimes banks do what's called compounding instantaneously. All right, let me show you what that means. So what if we kept compounding more and more? So let's say I already talked about daily, that's n equals 365. Imagine if a bank paid compounded hourly. So the n would be how many hours there are in the year, right? If let's say it was by minute, so that would be how many minutes there are in the year. That's what n would be. And we could keep going like every second, every half second, okay? Now what would happen, so the limit of that, the extreme situation would be if you were compounding every instant, instantaneously, okay? Now you're going to get paid a ton, so it would seem like you're just going to get an infinite amount of money, but keep in mind that the amount of each payment is getting smaller. So you're going to have a ton of really super tiny payments. So it's not going to be that you're necessarily going to have an infinite amount of money. Okay? Here's the way we can start to attack that situation. Let's write the original formula with n, compounded n times per year. So it goes 1d times 1 plus r over 100n. And then we had ny. All right, I want you to do an exercise to show you that if it's compounded instantaneously, the answer is going to be d e to the r y over 100. Okay, remember e is the natural base, so you might be wondering how in the world did e sneak into this discussion. Okay, let me show you why it turns out that e snuck in. All right, I want you to do something on your calculator. I want you to do 1 plus 1 over 100n and to the n. Okay, I'm going to put this in a box, and I want you to calculate the value of that box expression for n equal to 100, n equal to 1,000, n equal to 10,000. Go as big as you can before your calculator chokes. Okay? You should get several decimals that are getting closer and closer to 2.71828. Okay? Well, doesn't that look exactly like what I said the natural base was? E. All right? So that's a little bit of the flavor to show you why this equation, this formula reduces to the one with natural base for the instantaneous situation. Okay, so let's do an example. Okay, so how much will 500 be worth if compounded? How much will it be worth after 9 years if it is compounded instantaneously at 3% for those 9 years? So you pause the video if you like and try to set up that. How much will 500 be worth after 9 years if it is compounded instantaneously at 3% for those 9 years? Okay, so what I would set up is 500 e to the 3 times 9 over 100. All right.